Matrix and welcome to Wazimatrix. My name is Luni and today we're focusing on your final exam prep for physical sciences. All you need to do to send us your questions and comments is search for Wazimatrix on all our social media platforms, as well as hit us up on our WhatsApp line. All of the details are on the screen. We've got a great assessment going on for you guys, so please download the 2Enable app for free on your app store. There's also a cool competition going on, but I'll give you all of those details later on in the show. I've got Nicolene, our sign language interpreter, as well as Temba, our teacher. Thank you so much, guys, and over to you.
Thank you, Luni. A warm welcome to all of you. Matrix. Today is our last push. Our focus will be on the chemistry, which is the paper 2. Now, we've got probably a lot of things that we can talk about, but because of time constraints, we'll focus our attention on certain aspects that would obviously, hopefully, contribute to the level of preparedness as we move towards writing the final exam for chemistry. So we would use some of the problems from the previous papers, but our main focus essentially will be on the strategies, the techniques in terms of how we approach questions. So without any waste of time, let's look at our scenarios here. The first question, which is adapted from DBE November 2019, okay, it's going to be our question 1 for today. It says here, the IUPAC name of an organic compound is 4,4-dimethyl pent-2-ine. Okay, so the IUPAC name is given in this case. Now, you'd obviously think about, this question is definitely around naming of organic compounds, or alternatively what we would refer to as the nomenclature of organic compounds. The IUPAC rules must be used with consistency. We need to refer to them and be consistent as far as their application. Right, so the compound IUPAC name is given in this case. Now it says here, write down the general formula. Pay attention to how the term general formula has been written, because once it's written in uppercase in this case, that's the main focus of the question. Okay, but before maybe we respond to the question, let's quickly interrogate the IUPAC name that's given. Now, one of the things that we obviously pick up from the IUPAC name that's given is the suffix, which is YNE. So the suffix on its own in terms of the naming, it has a lot to do with the homologous series to which this compound belongs. So we need to identify that. And from there, we are able to deduce, for argument's sake, the functional group of that particular homologous series, or based on the IUPAC name that is given. Right, so obviously this is an alkyne, okay? This is an alkyne, as the name suggests, YNE, which is something that is common as far as the given IUPAC name. So we want to identify the homologous series to which it belongs. So based on the given IUPAC name, we can immediately deduce that this compound is definitely one of the alkynes. Okay, so that's the homologous series to which it belongs. But the question says, write down the general formula. So all alkynes can be defined by the formula CnH2n minus 2. So this question is basically 1 mark. What that says is either you know or you don't, or you remember or you've forgotten. So go back and look at the classification of organic compounds as part of your preparation. Moving along, we've got question 1.1.2, which says, write down the structural formula of this compound. Right, now, we are going to go back and focus our attention on the given IUPAC name. So we've already identified the homologous series to which this substance belongs. Now, in terms of coming up with the structural formula, okay, we must show all the bonds between the atoms that make up a molecule of that particular compound. So first things first, let's pay attention to the parent chain. The parent chain, that's where we start. This parent chain consists of 5 carbon atoms in the longest continuous chain. So we're going to have 1, 2, 3, 4, 5. Right, so that's the parent chain. And then the 2-ine, so the 2 suggests the position of, the functional group in the parent chain. So in this case, we are saying that between carbon atom number 2 and 3, we've got the functional group. So the functional group here present is a triple bond. The moment we see a triple bond, we immediately think, oh, okay, this is an unsaturated hydrocarbon, which falls under a particular homologous series. It could either be, alkanes or alkynes, but in this case, it's YNE as the suffix that is given in the name of this compound, okay? So that's the position, okay? But remember, again, each carbon atom must have 4 bonds around it, as we know it from the periodic table, okay? So on carbon atom number 4, we've got 2 methyl groups, okay? Okay, then obviously this will be our 1, this will be our 2, this will be our 3, okay? Right? Just to correctly label that, okay? So we have, this is carbon atom number 3, that's 4, that's 5. So each carbon atom must have 4 bonds around it, okay? So at carbon atom number 4, we've got 2 methyl groups, okay? That's one. That's the first one, okay? Whichever comes first, okay? Then we've got another CH3, all right? Right. And then each carbon atom must have 4 bonds around it, okay? So this is what we have. You may be tempted on carbon atom number 2 to include, but make sure that you count the number of bonds, okay? And then on the third one, we've got another, carbon atom which has got another 3 bonds, okay, 4 bonds around it. So basically, if we can go back, we'll say 1, 2, 3, 4, 5. So between number 2 and 3, we've got a triple bond. And then on carbon atom number 4, we've got 2 methyl groups, okay, as substituents or branches, as you'd refer to it, okay, just to put it, clearly out there, right? So this is our structural formula of our compound. Okay, make sure that you show all the bonds because this is a structural formula. So our compound basically looks like this. So this is our 4.4 dimethyl pent-2-ine. So that's the first methyl, that's the other methyl. Both of them are on carbon atom number 4. So between carbon number 2 and 3, we've got the functional group, which is the triple bond. So pay attention to that as well, okay? Moving along, and then there's an organic compound below, which has 1 positional isomer. I'm going to underline that. So in terms of isomerism, remember, we talk of structural isomers generally. And if we further zoom into, the different categories of structural isomers, we definitely have positional, chain, and functional isomers. So these are some of the, little things that must come to mind, okay? And then it has got 1 positional isomer and 1 functional isomer, okay? So it says here, define the term positional isomer. What do we mean when we talk about a positional isomer, okay? So this is a positional isomer. So the question is based on a definition, okay? What are, isomers, because it should be in multiples, okay? So these are compounds, okay, with the same molecular formula, okay? Okay, same molecular formula, but, differ, okay, in the position, okay, of the substituent. It could be the substituent, okay, side chain, okay, these are different possibility, okay, or functional group, okay, in the parent chain, okay. So we need to go back to the examination guidelines just to remind ourselves what this is all about. So this definition entirely would be, 2 marks or nothing. So we must capture the correct words, in the correct context. In other words, what we mean that the keywords must be used in the correct context. When you read your definition, it should make scientific sense even to you, okay? So that's basically the definition, all right? Right, and then for this compound, write down the IUPAC name of its positional isomer, right? Now, first of all, let's identify the functional group so that we are able to identify also the homologous series to which it belongs, okay? Based on this functional group, which is the group of atoms that will give this substance its characteristic physical as well as chemical properties, we can immediately say, oh, okay, this is a ketone, all right? So now, if we are to write a IUPAC name of its positional isomer, this positional isomer should belong to the same homologous series, but differ in terms of the position of the functional group in the parent chain, right? So what can happen here is that we can shift the position in the parent chain, and there's only one possibility, which we have in this case. We can have CH3, I'm just copying it and changing the position of the functional group, okay? So that's, and then another CH, okay? Right, and then we've got C double bond O, right, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, and then 5, right? So this is same if a compound with the same molecular formula, but the position differs in terms of where the functional group is. So this is 1, 2, 3, 4, 5, while on this one it's on 1, 2. So the position has changed. The position of the functional group in the parent chain has changed. Right, so the focus on this question is on its IUPAC name, but the IUPAC name is based on this structural formula. In this case, this will be pentan, and then 3 on, okay? Now, it's still in the same homologous series, which is the ketone, but the position has changed from 2 to 3. So, and remember, we also mentioned earlier that the IUPAC rules must be used consistently. Make sure that you follow the rules, to the letter. And between a number and a letter, there must be a hyphen, okay? Between a number and another number, there must be a comma. Remember the 4.4, the 3 hyphen, that's how it works. So we need to remind ourselves of those very important rules, okay? Right, and then moving along, okay, for this very same compound, write down the structural formula of its functional isomer. Now, the functional isomer, it means, yes, the molecular formula is still the same. If we can write the same molecular formula, it's C5, and then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10, and then there is only 1 oxygen, okay? So the molecular formula will essentially remain the same. But these other compounds that we are going to write down, it should belong to a different homologous series. Why? Because it's a functional isomer, right? So for that, we're going to have the same number of carbon atoms, okay? The simplest one that comes to mind, okay? With same number of hydrogen atoms, and then we can have the oxygen at the end, okay? When the first carbon, okay? To be precise, okay? So remember again, each carbon atom must have 4 bonds around it, okay? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the structural formula of its functional isomer. Why functional? Because of that functional group, this compound, yes, is still C5H10O, but this belongs to a different homologous series. In this case, it is an aldehyde, okay? So be careful of that, okay? Now, this is not a positional isomer. Why? Because it belongs to a different homologous series, okay? Right, so that's the structural formula. And then there's a different one here that's given. Consider the condensed structural formula. Okay, is this a primary, secondary, or tertiary alcohol? So these are the three classes of alcohols that are given. Now, for you to be able to identify the correct one, you need to, it's recommended that you draw the structure. Okay, the CH3. Okay, I'll write the condensed, and then there's CH2. Okay, and then there's the C that's bonded to the functional group, the OH. Okay, and then that CH3 in brackets is a substituent. And then we've got another CH3, right? Now, this is the carbon atom, which is carbon atom number 2 in this case, okay, which is bonded to the functional group. How many alkyl groups are bonded to this carbon? We'll circle them. It's 1, it's 2, it's 3. For that reason, this becomes a tertiary alcohol. So this is the kind of, understanding that you need to demonstrate as far as naming is concerned. But these are just the examples, but the approach to answering questions on naming organic compounds, I think it's something that you need to go back, make sure that you revise and you remember most of the very important facts. Luni, I think for the first segment, we're good.
All right, thank you, Themba. Matrix, we are going to take a quick break and we'll see you shortly after this. Welcome back from the break, Matrix. I hope you guys are still enjoying the show. We are still busy with your final exam prep to help you with the upcoming exams. If you're constantly running out of data, then this next competition is just for you. Wazo Matrix is bringing you the hashtag Wazo Winner competition, where 2 lucky matriculants stand a chance to win 2 gigs of data. So all you need to do to enter is head on over to our Facebook page and all of the details will be there. Thank you so much, Themba, and over to you.
Thank you very much, Luni. Lenas, now we're going to look at the second question, which is based on, rates of reaction, which is a component of chemical change, And these concepts on chemical change, they're not entirely new at the level of grade 12. Some of the stuff we've looked at it in grade 10, some of it we've looked at in grade 11. So it's a build up to, the concept in as far as the broader reactions are concerned. Now, it says here, the calcium carbonate, which the formula is given in this case, is in an antacid tablet, reacts with dilute hydrochloric acid, okay, according to the balanced equation. So the equation has already been balanced for us. So why balancing of equation is, there's so much fuss about the balanced equation of reaction. Remember, if substances react with each other, they react in fixed proportion. And from that, we are able to derive the stoichiometric ratio in which they react with each other. And then we can so much do some problems around that based on the balanced equation of reaction. Right. Now, in other words, what this means in terms of, if we may interpret this, it says 1 mole of calcium carbonate reacts with 2 moles of the acid to give us a mole of calcium chloride, 1 mole of carbon dioxide, and a mole of water. So this is the stoichiometric ratio in which they react. That's what we need in as far as the stoichiometry is concerned. So the first question in this long question says, is the above reaction endothermic or exothermic? So this is, a multiple choice, just that here we only have 2 possible options. And beyond that, you must be able to justify your answer by way of reasoning. So in terms of energy, remember, we are given this information about this reaction, right? What does that tell us? It tells us that the enthalpy change of this reaction is negative. And remember, in almost all reactions, energy is absorbed to break the bonds, okay, as well as energy is released when new bonds are formed in a chemical change. This is how we know it from grade 10. So the comparison in terms of how much energy is absorbed versus what is released will determine whether the reaction is exothermic or endothermic. So a reaction that releases more than it absorbs is definitely an exothermic reaction, okay? So this is exothermic, right? Okay, that's a straightforward one. Okay, now we are supposed to calculate for the very same reaction the average rate of reaction in grams per second of this reaction. Now, there's additional information. It says after a period of 30 seconds, the mass of the tablet was found to be 0.25 grams. Initially, the mass was 2 grams. So the change in mass is from 2 grams to 0.25 grams. This change took place within a period of 30 seconds. Right. Now, I'm immediately tempted to, speak to what the concept of rate of reaction is all about. Because when you talk about rate of reaction in general, we're talking about the change in quantity of a substance per unit time. By how much does the concentration, does the mass, does the volume, it could be, the number of moles, but it should be confined to a time interval because we're talking rate. So that goes back again to your definitions. So the terminology is in the definitions. So understanding the definition is this is the first part, okay? Now, if we are to calculate the average rate of this reaction, so average rate of reaction, okay? Average rate, okay? It's supposed to be average rate of reaction, okay? I'll break it down. Average rate, okay, of reaction, okay, is equals to change in quantity, okay? In this case, the quantity is the mass, okay, or per unit time. So quantity can be mass, as is the case here. It could be volume, okay? It could be what? Concentration. It could be what? Number of moles, okay? All right, so just be aware. So the units will definitely vary based on whichever quantity we are focusing our attention on. So in this case, the change in mass is, at the end we are told that there is 0.25 grams, okay? So that's the final, 0.25 minus the initial mass, which is 2 grams. This change took place in half a minute, which is 30 seconds, right? So you'd realize that because this change in quantity involves a decrease in mass, so the value that we are going to get here will be negative. So the negative actually suggests that this is the average rate at which the mass is decreasing, okay? Then we go to our calculator, all right? So from the calculator, it's a simple and straightforward calculation, which is 0.25, okay, minus, careful which minus you use, okay, minus 2 divided by 30 seconds, right? So our final answer is negative 7 over 120, okay? Just to put that, this is negative 0.058, okay? So it's negative 0.058 grams per second. Okay, because the question says the units must be given in grams per second. Why? Because this is mass over time. All right, and then the next one, it talks about the same antacid tablet. We are told that it contains 40% of calcium carbonate. Now let's break that down. So if we say the antacid tablet contains calcium carbonate, it means a certain proportion of the tablet is actually calcium carbonate, okay? So the antacid is not calcium carbonate. It contains calcium carbonate, and the proportion of it is 40%, okay? So we are already told that the antacid tablet has a mass of 2 grams. So of the 2 grams, 40% of it is actually the calcium carbonate, which is what is of interest to us based on the equation of reaction that we are given, right? Then it says here, it's same mass, it's allowed to react completely. That's another part. So if the calcium carbonate reacts completely with the acid, immediately we are tempted to think, okay, it means the calcium carbonate that's contained in the antacid tablet is actually the limiting reagent, while the acid is in excess. So this reaction will only reach completion at a time such that all the calcium carbonate has reacted. So that's another implication that you need to think about and begin to interrogate. Okay, so it says here, calculate the volume of calcium carbonate, volume of carbon dioxide gas that will be collected at standard temperature and pressure. That's another very important aspect. assume that all the carbon dioxide produced is from the calcium carbonate. Now, if we go back again to our grade 10 stoichiometry, we talked about, that the fact that a mole of any gas occupies a fixed volume. So that is the molar gas volume, which is a constant. So when we say it's fixed volume, it means a mole of any gas, as long as it's under standard temperature and pressure, that mole will occupy a volume of 22.4 cubic decimeter. So that's why the figure is molar gas volume is equals to 22.4 cubic decimeters, okay, per mole. So if we say per mole, how many moles are there? It's 1. So 1 mole of any gas at STP occupies 22.4 cubic decimeters. So that's the main thing. And if you look at the number of marks that are given in this question is 5. It says to us this is a multi-step kind of a problem. So we know 1 produces 1. 1 mole of calcium carbonate produces 1 mole of carbon dioxide. And the assumption is that all the carbon dioxide produced is from the calcium carbonate. And calcium carbonate actually reacts completely because it is a limiting reagent, okay? So the calculations, because the SI unit of quantity of matter is actually the mole. So everything is about the moles. So the mole, that's the main thing. So we know that 40%, okay, of the 2 grams in the antacid tablets is actually the calcium carbonate, okay? So this is of 2 grams, okay? So here we're actually calculating the mass of sample of calcium carbonate in the antacid tablet, okay? So if you go to your calculator very quickly, okay, that's same as 0.4, which is the 40 over 100 multiplied by 2, okay? What is the mass of calcium carbonate? It's actually 0.8 grams. So 0.8 grams in the 2 grams of the antacid tablet is actually the calcium carbonate, which is what is of particular interest to us. So here the mass is 0.8 grams. Now we ask ourselves, in this 0.8 grams, how many moles of calcium carbonate are present? Okay, so we would say number of moles of calcium carbonate is equals to mass of sample divided by the molar mass of calcium carbonate. So the mass is we've managed to determine the 40% in the 2 grams. So this is 0.8 divided. Now we need to go to the periodic table to be able to determine the molecular mass of the calcium carbonate. So calcium is 40. Okay, let's quickly add that. So calcium carbonate is 40. Okay, calcium is 40. Okay, plus the carbon, which is 12. Okay, plus the oxygen, which is 16. But how many of them do we have per molecule? We've got per formula unit, there's actually 3. Okay, so that's how we determine that. But the information should actually be extracted from the periodic table. It's actually 100 grams per mole. Okay, so this is divided by 100. Okay, so how many moles are present in that? Should have stayed on the calculator. Okay, so then we'll have got the 0.8, okay, divided by 100. Okay, this gives us that, which is 8 times 10 exponent negative 3 moles. 8 times 10 exponent negative 3 moles. Okay, now what do we know from the balanced equation of reaction? 1 mole, okay, of calcium carbonate, okay, produces, so that's the main argument, okay, produces a mole of carbon dioxide, okay, gas. All right, now how many moles do we have then? It means there will be the same number of moles. So number of moles of CO2 gas is equals to 8 times 10 exponent negative 3 moles. Okay. Now we want to determine what volume will be that. So we know from our stoichiometry from grade 10, volume is equals to number of moles multiplied by the molar gas volume. Okay. Right. That's the second part of our multi-step problem. So the number of moles is 8 times 10 negative 3 multiplied by the constant, which is 22.4 cubic decimeter per mole. Okay. So then the final calculation yields, what do we have here? 8 times 10, exponent negative 3, okay, times the constant, which is 22, 4. So this gives us that 0,1792, okay? 0,1792 cubic decimeters. Okay, so this is the volume of carbon dioxide that will be produced, right? So this is a multi-step problem which is actually, doable as long as you understand. And if you look at how the calculations have been laid out, I think the scientific argument is very clear. One thing leads to the next. So as you respond to your question, you also need to make sure that the layout of your work, because somebody has to make sense of how you arrived at the answer, and all the calculations need to be shown clearly, okay? Right, and then the rate of reaction of similar antacid tablet with excess HCl of that concentration. So the concentration is given at different temperatures is measured, okay? A graph is plotted. So temperature is going to be varied. Now, this question actually talks a lot about, the scientific process, the investigation. Think about the variables, the independent, the dependent, as well as the controlled variable. So, and based on the results, we are able to draw conclusions, like in this case, this question obviously talks about, rate of reaction in one way or the other. So the temperatures are varied, which is different temperatures. So this is the graph that is obtained. So if you look at the label on the vertical axis, this is actually rate of reaction, okay? Because obviously, depending on the temperature, it will affect the time taken for the reaction to actually complete, okay? And then write down one controlled variable for this investigation. Now, we understand that temperature was going to be varied, okay? So obviously, we can think about the concentration, okay? But how did we arrive at that, okay? Remember, there are 5 factors that affect rate of reaction, okay? This is just one of them. But if we vary temperature, it means the concentration of the acid that is used in the reaction needs to be kept constant. So that's one of the obvious ones that comes to mind. We can also talk about the volume of the acid, okay? We can only talk about the volume of acid used, okay? We can also talk about the mass of the tablet, okay? All right. We can also talk about the mass of the tablet, but this question only requested that we identify one. All right. So these are some of the concepts that obviously come to mind. So just in conclusion, in this segment, the other question says write down the conclusion that can be drawn from the graph. If you go back to the graph, okay, you'd realize that as temperature increases, okay, the rate of reaction, this is actually a rate of reaction if you come to think of it, because the time taken to complete the reaction will depend on the temperature. So we can safely say that rate of reaction effectively increases with temperature. So what I've done in the conclusion, based on the information that was obtained in terms of the findings in the experiment or investigation, we realized that as temperature gets higher and higher, the time that it takes to reach completion it gets smaller and smaller. And once the time gets smaller or shorter and shorter, it means rate of reaction increases with temperature. And we've mentioned both the dependent as well as the independent variable. Loni, over to you.
All right. Thank you, Themba. Matrix, let's take a quick break and we'll see you straight after this. We're back from the break, Matrix. I hope you guys are still tuned in and enjoying the show. Thank you so much, Themba, and over to you.
Thank you very much, Loni. In our third and final segment, we'll look at the multiple choice question, which, you'd realize that the 20 marks in section A, you need to dedicate or allocate, a decent amount of time for you to actually go through them. Because some of the questions, actually, in most cases, the multiple choice tests your understanding more than any other thing in terms of, the concepts in its entirety. So as a result of that, the kind of skills that you approach, you need to polish them, make sure that you understand your basics very well. Let's look at a typical example, which is part of the assessment. And then it says here, a hypothetical reaction reaches equilibrium. I'm going to underline the term equilibrium. And remember, that's the main thing as far as chemical equilibrium is concerned. What exactly do we mean when we say a system is in a state of dynamic equilibrium? Remember, we are saying that there are two reactions that take place within a closed system, okay? There's the forward as well as the reverse. So these two reactions, they coexist or they occur at the same time. Hence we talk dynamic. Hence the word, completion is totally taboo. We cannot talk about completion when we talk about equilibrium. So in a state of dynamic equilibrium, what do we know? We know that the rate of the forward reaction equals the rate of the reverse reaction. Okay, and as a result of that, the concentrations of all substances actually remain constant as a consequence of equal rates of reaction. Okay, right? And then just to break it down, and then at a certain temperature in a closed container, according to the following balanced equation. So it's a hypothetical, but pay careful attention to that. This tells us something about the forward reaction. It says that the forward reaction is exothermic. Okay, forward reaction is exothermic. Now, we can immediately deduce that the opposite is true for the reverse reaction, okay? So which one of the following changes to the equilibrium conditions will result in an increase in the equilibrium constant? It's a brilliant question, right? Now, there are four options that are given there, okay? Now, there are three factors that affect equilibrium. One of them is concentration, okay? All right? And then the other one is temperature, right? And then the third one is pressure of gases, right? Okay, pressure of gases. Now, in these three factors that affect equilibrium, the principle of Le Chatelet is the main concept in terms of explaining how each one of those actually affect a state of a dynamic equilibrium, right? Remember, the temperature is very special because it's the only factor that actually affects, equilibrium or disturbed equilibrium. Now, just to analyze some of the possible options that were given, okay, the majority actually, it was split between option B and C, okay? With option A having about 15% of respondents saying it's A, and then D, we've got about 25%. But let's go back to the question itself, right? The only thing that can change actually the magnitude of the Kc value is only temperature. Now we're going to eliminate two destructors. Now if you choose at random from 4, chances are 25%, the chance is 25% of getting it correct. But if you eliminate the destructors, you improve your chances of getting it correct. But the thinking behind elimination is our main focus in this case, okay? Now, anything that talks about pressure is totally out because changing pressure does not affect the magnitude of the Kc. So we'll eliminate C and D, and we're left with A and B. So whatever, and then again, it talks about the magnitude of the equilibrium constant. I'm tempted to talk about the Kc expression, right? So if we talk about the Kc expression in this case, we know that the Kc expression in this case is we're not gonna include this product, which is carbon, because it's a solid. So we shall give it a concentration which is constant of 1, and then we've got what? We've got A, okay? And then a B, do not forget, B must be squared. So this is our Kc expression in this case. Now, the question talks about the one that is going to result in an increase in the equilibrium constant. So now, for the Kc value to actually increase, it means the forward reaction must actually be favored. So if we favor the forward reaction, it means the proportion of these reactants in the equilibrium mixture will actually be less. Hence, if this becomes less, then we get a bigger magnitude of Kc. So in terms of temperature, if the forward reaction is favored, it means the Kc value will also increase. Now, A says if we increase temperature, remember the forward reaction is exothermic, and the exothermic is favored by a decrease in temperature. So A will have an opposite effect. So if we decrease the temperature, the forward reaction will be favored, meaning the magnitude of the Kc value will increase, right? So the correct option in this case is actually B. But pay careful attention to the distractors that we eliminated, and we are to think about the reason why between A and B we eliminated A, right? So that's basically one of the skills that are very important as far as the multiple choice. And then further on, it says here, it's another question on the multiple choice. It says, initially, a certain amount of gas P was placed in an empty container. There is a hypothetical reaction which reaches equilibrium. So that's the main thing. And this equilibrium can only be achieved in a closed system, okay? This is the balanced equation, okay? And again, we need to pay attention to that, okay? That still says the forward reaction is actually exothermic. And then meaning, by implication, the reverse is actually exothermic. So at time t, the temperature is increased, right? So which graph below best illustrates the resulting changes in the rates of the forward and the reverse reaction if after temperature is increased? So the main idea here, or the main factor, is temperature. So, but the change that was effected is actually an increase in temperature, right? Now, think about the kinetic molecular theory as we know it from grade 10, that if you talk about temperature of a substance, for argument's sake, it has to do, with the average kinetic energy of particles of a substance. And if you increase, according to the the collision theory, if you increase temperature of any reaction, okay, what happens is the average kinetic energy also increases. So increasing temperature effectively increases the rate of any reaction, be it exothermic or endothermic. However, according to the Le Chatelet's principle, then we must decide as to which of the two reactions in that closed system is actually favored. So in this case, let's identify the distractors, okay? That's the first thing. But before that, let's look at some of the analysis in terms of the responses. Again, we still have a lot of people saying B and C, okay? And then very few saying A, which is about 15% or so, and then D followed by D, which is about what, 25%, okay? So if I can quickly go back, let's identify the distractors and think about the reason as to why those options are actually incorrect, okay? So we have identified, and we appreciate the fact that when you increase temperature of any reaction, the rate of reaction increases, irrespective of the fact that it's an exothermic or endothermic reaction. So obviously A is out, okay? Because it says at time t, when we increase the temperature, the rate of the reverse reaction decreases, which is not what temperature does, okay? But there's something special about option D, okay? If you look at option D very carefully, at time t, when temperature was increased, both reaction rates increased, but none was increased more than the other. So in other words, we can simply deduce that none of the reaction was favored over the other. So that could point to a possibility that a catalyst was introduced at time t, okay? But remember, a catalyst actually lowers the activation energy of any reaction, and as a result of that, the rate of reaction increases. Now, if in this case, according to graph D, we are saying that both reactions rates were increased, but none was favored. So we will take out D as a distractor as well. Now we are left with option C and option B, right? Now, we need to go back. We know that the forward reaction is actually exothermic. The enthalpy change of the forward reaction is negative, right? And then for the reverse, it is positive, okay? So increasing temperature will actually favor the reverse reaction, okay? Now, A, C, and D are actually the opposite of the other in terms of which of the two reactions were favored. According to option C, the forward reaction was favored. As you can see, at time t, the rate of the forward reaction is greater than that of the reverse reaction. While both of them increased, the forward reaction actually increased more than the reverse, which takes it out. Okay. So what happens is with option B, we realize that despite the fact that both reaction rates increased, but the one that was favored is the endothermic one, which is the reverse, which leaves us with option B. So that's the kind of thinking. Look, it takes a decent amount of time to actually work through all those steps. So these are some of the little, tips that you need to be mindful of as you approach your multiple choice questions. And a question with 20 marks deserves, a fair amount of time, because the level of difficulty will always be different from one question to the next. So, yes, as you do it last, but allocate a fair amount of time in responding to the multiple choice questions. Right? Okay. And then it's fine in terms of the final tips as far as the general paper 2 is concerned. Okay. Just to go over some of those that I've mentioned during the course of our discussion. It says it is highly recommended that you do not start, okay, with the multiple choice questions, since they actually cover a broad range of topics, okay, of the syllabus, as opposed to the long questions that focus on a particular topic, okay, right? We are fine with that. We have addressed that. The one more important thing, familiarize yourself with the periodic table. This is a very valuable tool, as well as the standard reduction potential tables. Now, from the standard reduction potential tables, you are immediately able to, extract some of the chemical formulae of complex ions, like in fertilizers, you talk about the ammonium sulfate, or ammonium nitrate. So the standard reduction potential tables have some of those. The periodic table gives you the valency of some of these elements, as far as the reactions are concerned. So the part of the chemical formula in terms of its importance cannot be overemphasized. It's very important to understand the chemical formula as we know it from grade 10. Okay, so and then you must link your definitions to the formula sheet, okay? So the formula sheet is something that you need also to familiarize yourself with. So those are some of the tips as far as, responding to the multiple choice, as well as the approach to answering these structured questions. We certainly hope that, the discussion will contribute in terms of, adequately preparing you. But very important, go back to the examination guidelines, know your definitions, make sure that you understand the keywords and you must use them in the correct context. So as far as, the prep, we can only do so much, Loni, given the time that we have. Over to you.
Thank you, Temba. Matrix, we're wishing you everything of the best for these exams. Please use our study resources to help you prepare, and remember to ask us any questions and comments if you've got any. Congratulations to all of our competition winners who will be announced after the show on our Facebook page. Remember to check out the schedule on www.wazamatrix.co.za, and if you missed any of the shows, they are available on our YouTube channel. From me, Luni, Nicolene, and Temba, thank you and goodbye.